We are now looking, we're looking more at proofs. Our last thing we looked at right before our quiz was classifying triangles and proving certain types of triangles. And now we're going to do quadrilaterals. So now instead of 3 sides, we're going to have 4 sides. And there's slightly more options. So we need to define our different types of quadrilaterals. Again, most of these shapes we probably know. Trapezoid, rhombus may be new, but for the most part, we probably know what these shapes look like. So a trapezoid is a quadrilateral with one set of parallel sides. One set of parallel sides. And a trapezoid, it looks like that. So this side and this side are parallel. The other thing I'm going to do is highlight here parallel sides, right? Meaning if I'm going to prove something is a trapezoid, I need to prove those sides are parallel. And we know with parallel sides, we need to find slope, right? So kind of thinking about these things as we're going through our definitions. All right, our next one. A parallelogram. All right, parallelograms look like this. They're kind of like tilty rectangles, okay? So it's a quadrilateral. I'm not going to rewrite that every time. So here's some good notation for you as you take notes, especially in like college, as professors go really quickly through things. Anytime you see those lines, it means you're just repeating the same thing. So instead of rewriting a quadrilateral every time, I'm going to write those little lines. Quadrilateral with 2 sets of parallel sides. So again, we're talking about parallel sides, which again means we're going to be talking about slope for those. So again, so with a parallelogram, those 2 sides are parallel to each other, and then this and this are also parallel to each other. So I have to check all my sides for being parallel. Then we have a rhombus. A rhombus is a type of parallelogram. It kind of looks like a diamond when you tilt it on its side. I'll go through the definition. A rhombus is a parallelogram. It's a certain parallelogram with 4 equal sides. This is a parallelogram with 4 equal sides. So not only are they all parallel, but all 4 of those sides are the same length. Okay? So now, once we're talking about equal sides, right, how can we prove something has equal sides, right? That's what we just, that's what we just did with our triangles, right? Alright. So as soon as we're talking about equal sides, right, we're going to be finding distance or length, right? Just like we did with our triangles. Then we have a rectangle. And a rectangle is also a parallelogram. So I said a parallelogram is just like a tilted rectangle because most of us are used to rectangles, but really a rectangle is a certain type of parallelogram that's straight up and down. So we say it's perpendicular, right? Adjacent sides. So I think we all know what a rectangle looks like, right? So it's a parallelogram, so this and this are parallel, this and this are parallel. Don't care if all the sides are equal, it doesn't have to be a rhombus. We'll get to that next, with a square, right? But with a rectangle, right, I also need those sides to be perpendicular, so I need that right angle, which makes sense with what we should already know about a rectangle. Yeah. And then we have a square, right? And a square is this particular rectangle with 4 equal sides. Hi, Miss Payne. Hi. How are you doing? Good. So everything with a rectangle, parallel, right? A perpendicular. Now they all also have to be equal. So the square is like the most crazy of the shapes, the most to prove, right? With perpendicular, right? Okay, so perpendicular gives a slope, and then 4 equal sides, right? Again, that's distance or length. So all of these things, proving all of these things, really just comes from the 2 types of things we already know how to do: finding slopes or finding distances. So the biggest thing is figuring out how you're doing all this. So I created this flowchart. I think on yours, I already fixed it, but this lines, are the sides congruent? This line should go here, and that should say no. I don't know if I fixed it on yours yet. So the first thing you always do is find the slope of all 4 sides. If nothing's parallel whatsoever, you can't really say anything about the shape. It's nothing. It's just a quadrilateral with no special properties. Okay? If you find that one set of parallel sides are parallel, then we say it's a trapezoid, and you're done. There is nothing after a trapezoid. There's no other shapes that are a trapezoid, just more special. Okay? And then if there's 2 sets of parallel sides, it's a parallelogram. Okay? But remember, then we had a rhombus was a special type of parallelogram. A rectangle was a special type of parallelogram. So if we know it's a parallelogram, it can still be other things. So we have to ask ourselves the next question. Are the adjacent sides perpendicular? So do they form a right angle? Yes. Right? Oh, it's a rectangle. No. We have to ask ourselves another question. Okay, so let's say it's no. Okay, then the next thing we have to ask ourselves, are the sides congruent? Yes. Then it's a rhombus. No, it goes back to parallelogram and it just stays there. So if your sides aren't congruent, then it's a parallelogram. If those do form a right angle, it's a rectangle. Then you still have to see if your sides are congruent. Okay? And if yes, it's a square. We're going to go through a lot of examples with these. But the first thing you do is slope. And then you do distance, always. If you always do both of them, you should be able to figure out exactly what it is. The only issue is sometimes you don't have to do both of them depending on what you get for your first answer. So let's look at an example on our next page. So example 1 says classify a quadrilateral A, B, C, D with vertices at 4, 7, 9, 7. So I'm going to start drawing these. 7, 6, 7, 8, 9, 7. 1, 2. So the first thing, if you look back on the last page at your chart, is to find the slope of all 4 sides. So I'm going to do M, and then I'm going to put a B underneath, just so I know exactly which side I'm finding the slope of. So slope is rise over run. This is a horizontal line, so if you look, I am from here to here, I'm not going up at all, but I'm going over 1, 2, 3, 5, which is just 0. Okay. Then we have the slope of BC. So from B to C, we go down 4, make sure you're paying attention to negatives, and left 3. Right, and again, a negative divided by a negative is positive. Then the slope of CD, again, rise over run. I'm not going up or down at all, and I'm going over 5. Okay. And then B to A. Up 4, over 3. So, I'm looking to see if I have parallel sides, where parallel have the same slope. So, these ones are the same, and these are the same. So, I have 2 sets of parallel sides. Alright, if you look back at your flow chart, if you have 2 sets of parallel sides, we already know this is a parallelogram, but we have to check if we can be more specific. So our next question, right, if I look down here, our next question after we figured there's 2 sets of parallel sides, are they perpendicular? Does it form a right angle? So, I'm going to look at my sides that are next to each other. So all I have to look at is here and here. And I hope we can see that 0 and 4/3 are not perpendicular. You can also kind of look at your picture to help you out too. Those lines do not look like they form a right angle. So this is not perpendicular. Then our next question, right, are the adjacent sides perpendicular? No. Are the sides congruent? So now I have to find the length of my sides. So I'm going to do the same thing I did here. The distance of AB. Well, A to B is easy. I'm just counting. That's 5. The distance of BC. Well, I have a distance of 3 and 4, so I have to use Pythagorean's theorem. If you use the negatives, that's fine. Just make sure you're putting those negatives in parentheses. Right? Because then a negative times a negative is positive, so it doesn't really change anything. So this is 5. The distance of CD, again, I can just count because it's a straight line. It's 5. And then the distance of D to A, I could set up the same thing, 3 squared, X squared. And again, we should start recognizing that this 3 squared and 4 squared and this 3 squared and 4 squared will give us the same answer. So, what do we know from this? All 4 sides equal. So again, going back, if all sides congruent, the answer is yes. It is a rhombus, and that is it. We are done. Well, I would just write that this is a that is all we're going to do. We're going to do more of these problems for our video tomorrow. We're going to practice these a lot in class, so have a great rest of your day, and I will see you guys tomorrow.